Ribbit. Alright, full screen this. Try that keycast mode again. Alt X Sly, enter, or start up some Sly. And, you know, I'm so used to just playing around on the Rebel. I noticed the last time I was doing one of these videos. Control X3 to split it that way. That I'm having to scroll around to show stuff because I'm not actually creating a file sometimes. So I don't know. I think I'm just going to roll on the REPL this time. But maybe I'll start making files more often or something. So today I want to go over like prog. And I guess I'll go over some of these other guys too, but prog stands for program, I guess you could say. And I think it's more archaic to use prog. And maybe in the past it was originally used, I think, but I'm not sure about this because like function forms, which are lambdas, these lambdas are couldn't have multiple bodies. So I want to say like if I define a function, whatever, and I say like print hi, and print by. Of course, this isn't a proper function because I didn't name it, so maybe I should name it. Whatever. That maybe in the old days, maybe in the function or in the lambda itself, you couldn't have two of these bodies, like two of these forms inside here. I don't know this for sure, but I think this is where maybe some of this stuff came from, but I'm not positive about that because I don't have like an old Lisp to try out. I've been trying to find an older Lisp to see if I could test some of this stuff out, I guess. And I don't know that this is used too often nowadays because structured code became so much more popular. But prog is a way to do, let's say, unstructured iteration. I want to type that out because it's just goofy. I'm talking. So unstructured iteration, let's say. And there's also a prog star, which I haven't played with yet. But it's kind of like what a let star is to a let. It just lets you like use the bindings of previous variables or whatever. I think it has to do with like, it's gonna, instead of setting all the variables in parallel, let's say, it sets one and then the other one and the other one and the other one in a sequence so you can use the previous. So if you say like A equal 10, then you can say B equal A plus 1, let's say. Where let you can't do that. In prog you can't do that. But a let star and a prog star you can do that, let's say. And then the first form in a prog, so if we do like prog, let's say x2, just for a simple one, the first argument is variables. And I want to say it's kind of like a let, so I think I want to put this like this. And then I could say like you can return from this. So I could say times x, let's say. And so we can get 4 back. So it's, I don't know, it's very similar to a lambda kind of, I guess, or a let, or a function kind of, I guess. I don't know. But you can put this inside your function, let's say. And then if you have just an atom sitting there inside your prog, then you can go to it or jump to it, let's say. So it's kind of like a go-to in a way also. And that's how you're going to do the iteration. So I want to say you can do no local variables. And in this case, we'll go like prog, probably just like this. And then let's just say like burp. So this returns nil because I didn't return anything. So since I guess nothing's returned, so I could do the same thing maybe, and then print this, and then this is probably going to print burp and then return nil. And then if I actually wanted to do no arguments, let's say, and then I could just return burp, and then I actually get the return back out of there. And then to do simple iteration, let's say, so if we do a prog, and then we'll set a variable like x1, let's say, and then, I don't know, let's just do an I, a 0. And then this is where I can just put an atom. So we can say this atom is a label. This can be named anything, and it's not quoted either. So I'm not putting a quote in front of it. I'm just throwing an atom out there, let's say. And then we could do an if construct. So let's just go up to 8, let's say. So if I say if greater or equal I8, then return x. And then now I'll set fx to times x2. And then let's inc fi. So it actually goes up to 8, or else I'm going to get stuck in a loop. And then now I can say go, and then atom, and then put a label here. And then it runs up to 256. So I guess with that said, then let me Control L, move my cursor out of the way since it's highlighting stuff. Leave that there because maybe this won't be too long. So I want to say now we could now wrap this inside a function, let's say. So let's just do like a prog length. So we have length of a list, let's say. Length 1, 2, 3, 4, 5. So we get 5 back, right? So now if we say like define prog length, and then give it a list, and then now use prog as the looping construct. And like I said, this is unstructured looping versus a lot of this other stuff in like loop and do times are structured looping. So I'll just put repeat because it can be any atom that I'm going to jump to. And then I'll say if. Let's say if we have an atom, so if list is an atom, then return len, which is up above. And so let's set f len to be 1 plus len. And then set f the list to be the cdr of the list. And so we got len and list, and so from here we could say go repeat. And then I want to say this will work like the other one. So length, and then I had 1, 2, 3, 4, 5. So there we go. So it's just like you can set variables and stuff. I didn't have to do any kind of looping if I didn't want to, but then I can also loop inside here. So I don't know. Like I said, I think this is more of an archaic type of structure that I've never even seen this before. I didn't even know about it. So I just found out about this the other day when I was looking at an old Lisp book. And then that led me to some of the other stuff. Like I did some of these in the other one. So it's like a prog1, there's a prog2, the progn, which is pretty popular. So I'm pretty sure most people have seen these. And then there was another one, progv, which I never heard of. And then there's is it multiple, value prog1, multiple value prog1. And I think I'll just go over these, although I've gone over the prog1, 2 and ends before. The v and the multiple values I haven't ever, like, especially the progv, I'm not even sure. Like, I don't really understand that one too well, but I'm going to try to explain it anyway, because helps me to remember this stuff and maybe understand it a little better if I try to explain something that I'm not all that familiar with. So first I want to like set up a special variable, and I guess I could have used def var, but I'm so used to just using def parameters because one time in a video I used def var and I was trying to reset that variable with a def var and it wasn't working. And it was just because I was reloading the code rather than typing it, I think. And even to the end of the video, I couldn't figure out what the issue was, and that's what it was. After the video, I was like, man, I was using def var. So I did a pop function versus a pop macro. So this is just kind of a review real quick. So if I do like, without making a function though. So if I say prog1, I have the nums up there, let's say, and then I'm going to do car nums. So prog1 is going to return the first form, first XP, first thing it evaluates. I don't know how to explain that, but I'm just going to call it a S expression. So the first S expression is going to return that one. Well, I guess form's better because, I mean, nums by itself is a S expression. So the first form, I guess, would be a better way to say that. And then I'm still going to set the cdr of the nums. So normally that's what it would return. And then you see, if I look at nums, then it's popped off. So one's gone. And I guess that's like if we just do pop, let's say, pop nums. And then control C, control M, and sly will macro expand this. And you can see that it's using set Q instead of set F, but the common list pop is actually just a prog1, car in the nums, just like I carved the nums right here, and then set Q nums, cdr nums, which is the same thing right here I did. The only difference is like it's using set Q because set F is going to expand to whatever it needs to be, whether that be R placa or set F or set Q or whatever it needs to be, I guess. And so prog2, it's just the opposite of that. I guess it returns a second thing. So if I had this and I was like plus 1, 1, 1, and plus 2, 2, 2, and plus 3, 3, 3, then it's going to run the second one. It runs all these. Actually, all these are getting ran. It's only returning this. Just like it only returned this car, let's say, but it also set F the nums to the cdr of the nums right there. So it's still evaluating everything. It's just what's being returned, I guess. Which I guess I could show that too with maybe if we just set another variable, then we'll see that I guess Lisp is only caring about maybe I'll use a def var this time. So if I say def var tree, and then use a prog1, let's say, and then I'm going to print watermelon. And then I also want to print, I don't know if is it funky, like typing it all out on one line? It doesn't matter, but maybe on the next one I'll do it the other way. So now it prints watermelon, it prints grapes, and it's returning tree because I just set def var, so it's setting this special variable. Then it's going to return tree, but what this prog1 really returned was watermelon because it's a prog1. So tree is now a watermelon tree, let's say. And then now if I use set F, I'm going to set F tree to be a prog2, and then let's just do the same thing. So set F tree, and here I'll return it this way. Print watermelon, and then print grapes. And I guess what I didn't go over in this video is the indentation changes. So prog1, it's going to have all these, I guess, because it's a prog1, it's just one. And then it's letting you know this is the one that's returning, and everything after that is like indented different. And so here, prog2 is what's returning, so everything after that is indented different, let's say, because I could keep going. And so then over here, now, if I check out tree, I have a grape tree instead, because even though it's printing both of these, the second one's what's being returned, and that's what's getting thrown inside to setf. And up here, it was the first one that was being returned and thrown inside tree. So now I have a grape tree instead of a watermelon tree. And then progn, I'll explain that, but I think anybody using Lisp for a while has probably seen those. So we have a progn that's just going to return. So if I was to say like, oops, like A, B, wow, it's so hard to type ABC for some reason. I'm like, what did I do with this unmatched parentheses? It's just returning the last thing. So it's going to evaluate everything and return the last thing. And this is just useful whenever something like if comes along and you say, if, 0 equals 0, then I want to print, let's just say French, and print fries, toast, French toast. And then I'm going to get French. But I can't say, let's say I wanted to print French and toast, then I couldn't do that unless I wrap this in a progn, let's say, or in some kind of body that takes more than one of these. Whoa. When I hit tab and it doesn't do what I'm expecting. And then after that, I'll just say print fries, which I don't really have to use a print right here. But since I did on the other two. So I'm getting to print, run both of these commands, where the if only accepts, the if and the else. Now I have both of these being in an if block, and this being in an else block, let's say. And then there's this multiple value prog1, is that what it was earlier? Multiple value P1. And so I want to say this is maybe what's unique about this is it returns multiple values. It accepts things that return multiple values. Is that a better way to say it? Because values is going to return multiple values, let's say. So if I say like a taco truck sickness, let's say, then this by itself, what am I trying to do? Like, this by itself can return multiple values, right? And then this multiple value that I actually messed all this up. So let me just go MVP. Will that do it? No, but I could have said MVP1, and that'll give me what I want. And I'm guessing I could do it like this. And then now I'm going to say values. And then, I don't know, like a pink tractor trailer, let's say. And then notice, this is like the prog1. You would think this would be returned because it's the last thing, and Lisp usually returns the last thing. But I'm overriding that with this. And so it's returning this set right here. And I don't know how to make this, like, I guess we have nums already, so let's just set f nums back to what it was. It was 1, 2, 3, 4. And then, like maybe kind of the same way as the popping a stack that I was doing a minute ago. If we just did the same thing, so MVP1. And then say like values and that list, values list nums. And so the same way that values returned, let me just cut that in that value list, let's say nums. Same way values returned multiple values. The values list will return multiple values from a list, let's say. So if I put that back, just Control Y and Control W is how it's cutting and pasting. And then now I can say setf the nums. And now we'll just switch them to A, B, C, I guess, so it's more obvious. So now we're going to return nums, the 1, 2, 3, 4 like above, but we're also going to set f nums to ABC. So although it's returning 1, 2, 3, 4, nums is now ABC in the list. And so it's just a way, I guess, to maybe not have to use a let or something in here, because if normally it's going to return this, and if I want to return this, and this has to come first, let's say, because now this is changed. So since this is changed, I couldn't put this after that, but I want to return this. So I would have to use like a let variable or some kind of binding. I'd have to set this to be like something to be this and then return this after I set this, I guess. So it's just a way, I guess, like a little shortcut to not have to assign this to some value, let's say, and then set this. And then there's this progv one, which I'm the least familiar with. So I don't even know. Let's see if I can explain this progv. So progv, and I want to say like progv creates like dynamic bindings, and kind of like the prog has its own local variables, I guess. So I could say like progv, and then I'll just say trs, and then I'll set t to toe. Actually, I don't think this is going to work because t's a constant, right? It's the truth value. And so I'm getting the error. What? Veritas Eterna can't bind T. I've never seen this. Like truth, eternal truth. So I guess this is like Latin. This might be like an Easter egg, maybe. Veritas Eterna. I don't know how you pronounce that, but I guess it's just saying like can't bind T because it's eternally truth, eternal truth. So Q to get out of this right here, right? And just to see, like if I was to say like let T and try to change T to toe like I did up there, and then let's just return T, but let's just, to be explicit, let's print T. It's going to give me an error. Let T toe print. Common list T names a defined constant and can't be used in a let. So yeah, that's kind of interesting. This guy right here gives me a little Latin eternal truth. This might be like, probably an old Lisp did this, and it's just, you know, an Easter egg from a real old Lisp, whatever came up with that or something, maybe. So I need to change that. Let's see, progv to QRS, let's say, maybe. And then let's just, you know, use Q queen, R roach, rock, roach, and S could be salad. And then notice it's returning nil because I didn't tell it what I want to return. So then I think I have to add this, let's say an S or whatever I want to do. And look right here, it's returning this. And this is undefined variable. So this is like using, like it still worked. Like if I put values right here and said QRS. Oh, let me hit Control C, Control O to get rid of that trash. And then do this again. So it's working. I'm getting Queen Roach salad back, let's say, but this is complaining because these variables don't exist. So if I have to wrap this in a let or create these as like global variables, let's say. So let me just go ahead and should I put these in a let, or maybe I'll just do both because I think this has something to do with the explanation, let's say. So let's just do a def var and set Q to let's just put quander and then R to just do ballistic and S to stuff. Oops, too many of these parens. And then now I have QRS. So I could say like values QRS, let's say. And then they're sitting there. And now I want to say if I ran that thing I had above, now I'm no longer getting that error anymore. They're not errors, they're warnings. So, I mean, if this was on a file and I was running the file, you wouldn't see these warnings. But because I'm inside the REPL, then you see these warnings, let's say. Which, I guess you shouldn't. Let's say you shouldn't because it still works. But, you know, I see like the proper Lisp people complaining about don't use setf or different things like that to set a variable. Use def var or def parameter if it's going to be a special variable or a global variable. And then maybe this is where you can see like a difference between a special variable. So let's Control L this to get more into the middle of the screen. And how does this work? Let me think for a second. So if I do a progv and then so the values, let's just say the values right here is quander, realistic, and stuff. So maybe I'll just run that one more time and then get this to the top so we can start from here. And I'm just using Alt-P, Alt-N to move up and down inside the history list, I guess you could say. And then let's say if the variables are global, then because you can use a symbol value. So let me go ahead and do this. What is a symbol value? And then let's just say Q, right? So right now it's quander. Now, what's, I guess, unique or strange about the progv is if I was to say like QRS, and what was, I think I said like queen, roach, salad, just so I don't have to think about new words to put in here. And then now if I say values, and then let's just do QRS. So that's going to be the ones right there, queen, roach, salad. But then now I can say symbol value. And then if I was to put Q here, and then if I just go like this, and then go ahead and close this form, and then let's say S and R, then it's queen, roach, salad, because these are special variables. These global variables are special variables, let's say. And since they're special variables, then this progn's QRS overrides them. But if I put this in a let instead, so now let's go like this. So here we'll say let, and then QRS. Can't use T, but I can use U. VW, let's say. And so I want to say like U, let's just do under V violet and W water. And then that's inside the let. I close my let, I want to say. I'm not closing the let, but I'm closing the bindings for the let. And then now we'll do the progv. And then we'll just say UVW. And so now I'm setting these inside the progv. And then we'll use U. We're going to put them in a list. So the first thing inside the progv is the variables I want to set. And the second thing are their values, let's say. So the first list is setting the names of the variables I'm going to be using. And the second set is what they're going to be in the same order. So U is ugly, V is violent instead of violet, and W can be werewolves since they're violent anyway. I guess it could have been wolves though. And then now, let's just create a list. And then let's make the list have symbol value of U. And then here I'm going to hit Control Space to start selecting, and then Control Alt B to highlight that. And I'm just going to say Alt W to copy, Control E, and then enter, Control Y, enter, Control Y. And then I'll change this, to a W and this to a V. And then hit enter. And just to have this on a different line, UVW. And so what did I do wrong here? U is unbound. Retry using U as something else. All right, where did I go wrong? Oh, I think my progv does not end there. I want to put my progv down here. The progv is wrapping like the let, and I had closed it. Because like this let, to keep these bindings, I had to keep the let open. And same thing here, to keep these UVWs down here, I need to keep this progv open. And then enter. And then now you can see that by using symbol value, I'm pulling the progv's bindings, and by just using the UVWs without symbol bindings, I'm pulling the let's bindings. And therefore, you can use both, which I think this is probably the most interesting part about progv. I mean, I really don't know what to use this for, but if you wanted to use the same variable names and give them different bindings inside your program, then progv might be useful. Like I said, I've never seen it used, but I don't look at a lot of people's Lisp code. I'm just, playing around. And the only reason I know about this is because I found out about the prog earlier, and I started researching prog. And when I researched prog, I saw that all these other progs existed. And so I knew about prog1, let's say in prog2, because a lot of people use that to do like the pop example that I was showing. Or I guess because, like I said, like pop itself, pop stars, let's say, doesn't matter because Control CM, then, like you can see there's a prog1. So this is something I've seen. Now, maybe I've seen progvs before, I just never noticed or paid attention to it or, thought of the significance of it, I guess. But at the same time, I don't know how often I wanted. Maybe like if you had XYZ coordinates and you were doing something where these things swapped around for some reason, like, I don't really know, but like a teleport that teleported back or something. I don't know. I don't know where you use this thing. And then I guess the other thing is if I just did the same thing that I did here, and then maybe if I added one more of these in here, and then here I'll just like add Q and call it quack. And then come down here. And this, I've already showed it earlier kind of, but I guess there wasn't a let before. So here we'll use that. So we're setting the quack up there. And then down here I'm using it as the symbol value, and here I'm using it as the Q. And then you can see that the both of them are quack. So the same way that I want to say up here, where I had these guys and they were all the same. So the progv overrode the global variables to be what's inside the progv, let's say, the progv's bindings. I want to say these are called prog variables sometimes Like I said, I don't know how often people use these, but I think that's what I saw them call. And then over here, because this Q is the only one that's special, right? Because I set these guys up here. So Q, R, and S were the only ones that were special. So since the Q is special, then instead of taking the progv's binding like it did above, because there's a let around here, the special variable takes the let instead of the progv. And so like right here, if I was to hit Q, you can see it's quander still. So it's not changing anything. It's just if there's not a let, then progv bindings will override the special variable if it's there. But if there's a let, then the let's going to grab it, even though the progv is after that. Like the let's nested. So the let overrides the progv's with symbol value, let's say. But the let overrides the special variable, but the progv overrides the special variable if there's not a let around it, I guess. And I think that's pretty much. And I don't know if there's any more prog stuff. These are just the ones that I kind of. I looked at one and then started jumping around in the hyperspec a little bit, I guess, with these guys. But the hyperspec, I don't know, it's still kind of a mess to me. I don't know. I'm trying to think. Those are just local variables inside the prog, and sometimes they're called prog variables, I guess. That's all I gotta say, Robert.